Assalamu alaikum. Today's video is on transformation of functions. Let's get started. Here's the first one. When you have a transformation in this form, what does this mean? Well, first we'll have the mathematical explanation and then the simple explanation. Okay, so let's start. Now, when you have f of x plus a, this is a translation by 0a. What does this mean? Well, this is what it means. We will add a to the y coordinates and the x coordinates will remain the same. How does this work? Let's have a look. So here we have a graph of y equals x squared. That's the red graph here. Now we're going to see what happens when we have the function f of x plus a. As a is positive, the graph moves up because we are adding a positive number to the y coordinate, so it moves up. And as a is negative, the graph comes down because we are taking away a number. So this is a vertical movement, up and down. As we can see, this movement only impacts the y coordinates, the x coordinates remain the same. So if a is positive, the graph moves up. If a is negative, the graph moves down. So this is only a vertical movement. Now let's have a look at the next transformation, which is in this form. Well, what does it mean? Let's have a look at the mathematical explanation. This is a translation by the column vector minus b0. Well, what does this mean? You subtract b from the x coordinates and the y coordinates stay the same. This is a horizontal movement. Okay, how does this work? How does this work? Let's have a look at the diagram. Okay, so we again have the graph of y equals x squared, or f of x equals x squared, and we are looking for the transformation f in brackets x plus b. This is what happens. As b is negative, the graph moves to the right because you're subtracting a negative number. And if b is positive, then the graph moves to the left. So it's a horizontal movement, a sideways movement. Remember, if the value of b is positive, then your graph is going to move to the left, like it is doing so now. So when b is positive, you can see from the slider, yep, it's positive, it's moving to the left. And as the slider moves to the left, where it's negative values of b, the graph will move to the right. It's going in the opposite direction. So whenever you have an impact on the x coordinates, it will always be, the transformation will always be within the brackets, and you kind of always have to move in the opposite direction of what it is. So in this case, f of x plus b, so you got subtract b. Okay, so anything within the brackets in a transformation always impacts the x coordinates, not the y coordinates. Outside the brackets impacts the y coordinates. Okay, and hopefully this helps. So this one is a horizontal movement. Again, now if the value of b is positive, you're moving to the left, and if the value of b is negative, then you will be moving to the right. Please bear that in mind. Okay, now the next transformation is going to be in this form. What does this mean? First, the mathematical definition. This is a stretch parallel to the y-axis by scale factor c. What does that mean? Well, you multiply the y coordinates by c, and the x coordinates, they remain the same. So in this kind of stretch, it's as if the graph is being pulled towards the top and the bottom at the same time. Let's see how this would look for a positive value of. Here we have the graph, the green one, of y equals sine x. Now we shall see what happens as the value of c increases. The green graph is the graph of y equals sine x. Let's see what happens as the value of c increases. So we're going to plot c f of x. And we can see as the value of c increases, the graph is pulled both upwards and downwards, and it stretches out. So essentially you're multiplying the y coordinates by the value of c. I'm going to slow this down now. If we can see, when the value of c is less than 1 but greater than 0, actually the graph is shrinking. Again, it's the same impact. To keep it simple, multiply the y coordinates by the value of c, and the x coordinates remain the same. Now let's have a look at this transformation. First, the mathematical explanation. This is a stretch parallel to the x-axis by scale factor d. What does this mean? You divide the x coordinates by d, and the y coordinates remain the same. This is a squashing transformation, but the squash happens in terms of in a horizontal way, where you can almost imagine the graph is being squeezed in from the left and the right at the same time. Let's have a look. Now again, we're looking at the green graph, which is our original graph, y equals sine x. We're going to transform it using f of d of x. This is what it'll look like. We can see as the value of d increases, the more wavelengths of the graph, it's being squashed in from the left and the right. So we can see more wavelengths of the graph. It gets squeezed in and squeezed in and squeezed in. So let me just show you over here. If I can pause it at 5, right? So where you would have normally one wave, so you have one wave of y equals sine x. Over there you're going to have 5. 1. Oh, that's 1. Where you have one wave of the sine graph, there you're going to have 5 waves. So that's the first one, second one, third one, fourth one, and fifth one. Okay, and that's what's happening. It's getting squashed in from either side, left and right. So a quick way to remember this kind of transformation, always remember the second rule. You divide the x coordinates by the value of d, and the y coordinates will remain the same. That way you can't go wrong. This is our next transformation. How does this work? First, the mathematical explanation. This is a reflection in the x-axis. What does this mean? Multiply the y coordinates by -1, and the x coordinates, well, they remain the same. Let's have a look what this means on a graph. So the green graph here represents the function y equals x cubed plus 4x squared minus 5. That's our f of x. So we're going to find out what the minus f of x graph looks like. And here we go. You can see it's a reflection in the x-axis because all the y coordinates have been multiplied by -1. So when the y coordinates on the original green graph are below the x-axis, when they are negative, multiplied by -1, they move above the x-axis. Okay, and when the green coordinates, again, when the y coordinates of the green graph are above the x-axis, we multiply by -1 to get them below, and so on. Okay, so again, remember the simple rule of multiplying your y coordinates by -1 will help you plot the graphs properly. And remember, the x coordinates are not affected by this particular transformation. This is the last transformation we're going to look at today, and that's f of minus x. What does it mean? This is a reflection in the y-axis. Well, what does this mean? You divide the x coordinates by -1, and the y coordinates, well, they remain the same. So let's have a look what this would look on a graph. Again, we have our green graph, which is our original function. Now we're going to look at what f of minus x looks like. And remember, we said this is a reflection in the y-axis. So there we go. It's like the y-axis is a mirror line. Why is that? Well, we've divided our x-coordinates by -1. So wherever the x-coordinates were on the left-hand side, when you divide it by -1, they end up on the right-hand side. And where the x-coordinates were on the right-hand side, you divide them by -1, they end up on the left-hand side. Okay, remember, for this particular transformation, dividing the x-coordinates by -1 and leaving the y-coordinates exactly where they were will help you completely draw this transformation correctly. We'll have another video on a few transformational graph questions. That's all for now. Thank you for watching.